Europe, it's only 26% in this particular survey of people that think there's some connection between climate change and human activities, and that's something to worry about. Now, why is this the case? Well, it's very clear. The results of this survey depend very much on the type of question you ask. But what is clear is that the media, for a number of years now, has been emphasizing that there are two sides to the discussion. Some think that climate change is serious, well established. Some others think that it's not. And certainly public opinion reflects that. That's beginning to change, and I hope I'll have time to tell you some ideas why it's changing. But in contrast, the scientific evidence is really, the way scientists perceive this, the scientific consensus, I should call it, is really overwhelming. In this review, which is already some years old, it's 97% of the papers by experts. I have to here specify that this survey is done on climate experts or something connected with climate, including energy experts and so on, because there are many scientists that do not fit into this category. They just have opinions just like the general public. Okay? In fact, there's a more recent study. They surveyed, I think, 14,000 papers and so on, and only 24 were doubting climate change. So that's 99.8%. Okay, so the consensus is really overwhelming. And I should point out, if I have time, we know these 3% very well. It's not that we have ignored them. Okay, we have considered their questions very, very carefully, and they have been discussed in the literature at great length and so on. So the point is there's a very large discrepancy between public opinion and scientific consensus. And it's an interesting story. I won't have time to go into details, but this is, it's not by chance. There has been a very well documented and a very clear concerted effort from some interest groups to discredit the science. And of course, eventually this became part of in the U.S. in Congress has had an enormous influence, and of course the Republican Party has as a dogma sort of to distrust the science of climate change. That's beginning to change, but it was something that again the surveys done, for example, about the Yale groups attribute only to 15–16% of the population, people that are extremists in the sense of saying it's a hoax or it's really something we shouldn't worry about. Somehow or other that became 50% in Congress in the US. Okay, so anyhow, this is just the background. Now, why is there this consensus? Well, let me give you just in a couple of view graphs the sort of scientific background that we believe even children or high school kids should have in terms of how does the climate of our planet function. That's very well established. Here we have the planet. You cannot see, maybe I can ask somebody a favor if I could get a little water because I'm running very dry. You can see that the atmosphere is not visible. It's of course transparent, but it's very thin. It's like the skin of an apple. Okay, so that's why it's vulnerable. But mixing is very fast. So if you emit gases like carbon dioxide that last, in fact, for centuries or millennia in the atmosphere, it doesn't matter where you emit them. That's why we have global issues. The mixing times are months within each hemisphere and between about a year or two between the two hemispheres. Anyhow, the only thing that you see are the clouds. Okay. Now, basic physics developed at the beginning of the 20th century. Planck's laws that eventually, of course, led to nothing less than quantum mechanics. The black-body radiation law establishes very clearly that we should be able to predict what should be. Oh, thank you very much. Sorry about this. Anyhow, with very fundamental physics, one can predict what should be the average surface temperature of the planet, considering how much energy the planet receives from the sun, and that temperature is -18 degrees Celsius. Of course, that's not the case. We wouldn't be here because the oceans would be frozen. The point is that because we have an atmosphere, that turns out to be the temperature, indeed the correct temperature, but it's not the temperature at the Earth's surface. The atmosphere modifies that temperature because it absorbs some of the infrared radiation emitted. As you know, in thermal equilibrium, the planet emits to space the same amount of energy that it receives from the sun, but it receives the energy in the form of solar radiation, and then it emits it as infrared radiation, and the atmosphere absorbs some of that radiation and effectively functioning as a mantle, so that the average temperature is plus 15 rather than minus 18. Okay, and so the physics of all this is very well established. Interestingly also, again, something to know about the atmosphere, you probably know, is that this effect that we call the greenhouse effect is a result of the presence of trace amounts of certain compounds, because nitrogen and oxygen are transparent to infrared radiation. So if our atmosphere were to be very clean, we would be at minus 18 or even less degrees Celsius. Okay. But it has trace amounts of argon. Is an inert gas, it doesn't do anything, but carbon dioxide and water vapor. And again, by measuring carefully, my instinct is to lecture and to do this in several hours, but I'm going to try to be very fast, just as a professor. But anyhow, the point here is the following. Very well established, again from fundamental physics, that water vapor is the main gas absorbing this infrared radiation. It absorbs about 3/4, not all of it, only 3/4, and the amount of water vapor is very variable in the atmosphere, whereas carbon dioxide and a few other gases absorb the remaining fourth of this energy emitted by the surface. Okay. And carbon dioxide is present less than 0.5%. Well, here is what happens. What determines how much water vapor is there in the atmosphere? It's essentially the average temperature, because, as you know, we have unlimited amount of water in liquid form in the oceans. So it evaporates, it gets to the atmosphere, but the atmosphere only a certain amount can be in the form of a gas or as clouds, because it condenses and we get rain and snow. So the average relative humidity in the Earth's atmosphere is about 0.8 or so. So that's why the proportion there is variable, but that's sort of the average. But here is an interesting point. Let me see if I don't remember. Yes, I think no, I don't have it. So I'll just explain it to you very, very briefly. Because the amount of water vapor depends on the temperature, if you do a simple experiment, you remove carbon dioxide from the atmosphere, okay, with a few other trace gases like methane and nitrous oxide, water would begin to condense. And so in a matter of at most a decade or two, the average surface temperature of the planet would go to minus 18, actually below, to about minus 20, because you would have so much ice and so on that the planet would reflect more than the 1/3 that it normally reflects. So anyhow, this is the basic physics of the natural greenhouse effect. Okay, we're not talking yet about what humans are doing here, but it's very clear that a very tiny amount of carbon dioxide controls the climate, and that's why it's called the thermostat of the planet. And this is very well supported also by paleoclimatic studies. You can go back millions of years, and it makes a lot of sense when you do this. So in this context here, what happens? This is what human activities are doing to the chemical composition of the atmosphere. Okay, and there are many more details to this, but again, this is not in question. These measurements are relatively simple to do. You might argue with uncertainties a little bit, but they are very well established. So as you see, in the last 10,000 years, the amount was below 250 parts per million. Again, we're talking less than a half of a tenth of a percent, and suddenly jumps when, starting with the Industrial Revolution, but more strikingly since the last century. Well, that's something to worry about. If this is the thermostat of the planet, well, it's logical to expect that we should at least worry. Something might be happening. It turns out that this concentration we have now, which is, this is now a little old, but it's almost 400 now. It's about 40% more than it was in those 10,000 years. It's actually clearly larger than it has been in the last 600,000 years, and in fact for several million years as well. So this is quite unusual even for our planet. It has been higher, but you have to go back something like 50 million years or so. Okay, another set of measurements, which at some point were controversial, but they're now very, very well established, and that's the temperature of the planet. Notice I'm showing you two figures with just measurements, the results of measurements. There's no climate theory here yet, and this is temperature. And of course, in recent years, thermometers can do the job. There are many of them, so you can specifically look at the deviations from their average values and so on. And in past years, you have to look at proxies, the width of tree rings or sediments in the oceans and so on and so forth. And that's why there are uncertainties. But very clearly, the temperature has gone up in just particular since the last century, in the 20th century. Not very much, less than 1 degree Celsius, about 0.7, 0.8. And so the question is, are these two connected? And that's where the scientific consensus comes in, as represented, for example, by the Intergovernmental Panel on Climate Change that has reports every 4 years or so. One is about to come out probably at the end of this year. But anyhow, the consensus is that, yes, as expected, this temperature change is connected with a change in chemical composition, because that's what physics tells us. But there's one complication. The climate is actually very complicated. The basic physics, very well understood. But the details, if you want to quantitatively express the connection between temperature and composition and so on, there are complications, particularly in terms of future projections. Specifically, it's difficult to predict the detailed role of clouds. They reflect 1/3 of the solar radiation coming in the form of the solar energy coming in the form of visible radiation. But they also are active greenhouse components. They also absorb infrared radiation. So anyhow, the bottom line here is that the scientific community is very cautious and say, okay, we recognize that we cannot tell with absolute certainty that this temperature increase is a consequence of the change in the chemical composition. But we can talk about probabilities. And so looking at all the papers, looking at attribution studies, it's several thousand scientists working together for months. I was part of working group 1, the science group. Anyhow, the consensus is, okay, we can only talk about probabilities, and so we believe that the temperature increase is a consequence of human activities, but only with 90% probability. Okay? So there's some chance that it's natural, but it's not a very big chance. Okay, and this is just looking at the data. Okay, so why worry about this small temperature change? Well, it's not just temperature. We know the glaciers are melting, not all of them, but most of them, mountain, river, glaciers. But we're beginning to see events like this, floods increasing in all the continents, wildfires, which are a consequence of droughts and so on, also increasing, and again, just particularly in last century. So the question is, are these extreme events connected with climate change? The scientific community is very conservative. They examine each other very carefully. So 2 or 3 years ago, the consensus was, hey, well, we just don't have enough statistics to be able to tell. That changed. In these last 2 years, a number of papers have documented now very clearly that there is a link, but it depends very much on which question you ask. You cannot tell that the specific event was caused by climate change, but you can tell whether its intensity was increased by this temperature increase that we have. Of course, there's more energy in the system, and so on. So, for example, the one that is easiest to understand is heat waves, because they're satellite measurements. Again, this does not involve climate models. This is just measurements from satellites, and if you focus, as Jim Hansen and his group did, on northern latitudes, and looking at the satellite divides the planet, of course, in certain areas and so on. And so you just measure, record the temperatures measured by the satellite, and of course, in agreement with this temperature increase we just showed, the temperature is shifting to the right, it's increasing. But if you defined an extreme heat wave, extremely hot summer, as one in which the temperature departed 3 standard deviations from the mean, as it was in the 50s, then it turns out that these extreme heat events, the probability has increased something like 40 times according to this just purely statistical calculation. So that means that, for example, the anomalies we had in southern U.S., northern Mexico, they fit with these statistics. Again, you cannot be sure that it was specifically climate change, but you expect it to be much more likely. Okay? And in fact, what had a big impact in the United States, also on public opinion, the hurricane just before the election, actually, which helped Obama in some sense, were pushing for climate change. But again, papers and studies have looked at this, and it is just very unlikely that events of this sort would happen just by chance. The probability has clearly increased, and this is understood by the physics, the amount of energy in the system, and so on. So that's the worry, not just the small temperature increase. Okay. So what is society doing about this? Well, there is one consensus, which is interesting just to quote just because the way it came out. You know, there are the so-called Conference of the Parties by the United Nations Convention, the Framework Convention on Climate Change, and so on. So this group from the United Nations gets together every year. I'm quoting here what happened in 2009. Subsequently, there was another meeting in Cancun in Mexico. And unfortunately, so far they have not agreed on anything very substantial. Okay, not much has happened because of that. But the interesting thing in Copenhagen, I was there with President Calderon, is that there were more than 120, something, 130 heads of state. That's very unusual. And they discussed among each other. I was in some of the discussions. They were fascinating. But they all agreed, basically, hey, let's have at least as a goal, an aspirational goal, for the temperature, let's try to arrange things so that it doesn't go above 2 degrees. It has gone up already almost 1 degree. But the idea is let's do whatever we can so that it doesn't go above 2 degrees, because that begins to be quite risky. So that's where the 2 degrees come. Is it possible? Well, yes, there are a number of studies. This now begins to involve energy experts and economy experts. It's not just science now. Can we possibly do something so the temperature doesn't increase 2 degrees? By the way, that's already very unlikely. We haven't started soon enough. So 2 degrees is almost surely going to be the temperature that is going to, the average surface temperature is going to increase that, if not a bit more. But yes, what you can do is look at emissions of greenhouse gases, the main one being carbon dioxide, the main source being fossil fuels. Of course, there's also deforestation and so on, and something that has to do with photosynthesis. That's about 1/3 of the emissions. 2/3 have to do with the use of energy. Okay. So how can you deal with that? Well, if you look at emissions, you would have to arrange things so that they stop increasing, which is what's happening today. And yes, that can be done with these so-called wedges, which means the solution is at hand, but only if you take many measures simultaneously. There's no single sort of silver bullet. So you can do many things, and some of the obvious ones are use energy much more efficiently. We waste an enormous amount of energy in the different sectors, and we can use renewable energy sources and so on. But interestingly, if you look at the details, this comes now from the energy experts. Well, here's what, by the way, before I do that, I jumped ahead. If you look in more detail, more recent calculation, it's not enough to arrange things so that the emissions no longer increase. They have to decrease if you want to reach these 2 degrees or even 2.5 degrees nowadays, which means by the end of this decade, the emissions should be reduced by 1/3. One more decade by 1/2. That's an enormous change. That's a revolution, perhaps like a second revolution, second only to the Industrial Revolution. It started in the 19th century. Okay, so this is a very tough challenge, and that's why there are all sorts of opinions among energy experts, but they are reasonably well documented, and some of them indicate that yes, you can do renewables, but they have limitations. You can only do so much with renewables. So if you look long range, you will have to come up with better technologies, possibly even nuclear. In this PCAS report I was mentioning, we suggest not specifically to build nuclear plants already, although that's something that perhaps should be done in Mexico and in the US to keep up with the technology and the expertise that we have already. But certainly society should keep investing in better technology so that they are safer and cheaper also. One important problem is the cost, and we have problems such as proliferation, which is a political problem, very hard to deal with. But the other technology that at the moment is just too expensive is, well, sure, you can continue using even coal and of course petroleum and so on, but you have to capture and store the carbon dioxide. Amazingly, there are enough saline domes, there are enough cavities in the planet that storing them would not be a problem, but it is expensive. You have to make sure that it stays there. So at the moment, this only makes sense if you use the captured carbon dioxide to enhanced oil recovery projects. That means you use it to pump more oil, and we have in fact a project in Mexico where that might be happening, and certainly in the United States there are some of those. Okay, so let me push on, almost there. What would have to be done to really reach these aspirational goals that I was alluding to? The idea is really you have to interfere with the free market because it has very large imperfections, so-called externalities. So the market itself is not taking care of the solution. So a price on carbon emissions is perhaps the simplest solutions. And that's beginning to happen. For example, Australia has already done that. Even in India, there are some emissions from coal-fired power plants are taxed and so on. But this really should be a global agreement. In the United States at the moment it's difficult because international agreements have to be approved by Congress. Obama cannot do these sort of things. But there is a possibility because after all it would also help energy security and so on. But the other things that need to be done is, as I just mentioned, investments in energy technology research, working with developing countries. But win-win measures, those are the very clear ones, improving energy technology and so on. But let me sort of, I see my time is running up, so I'm going to try to stop here. But this is a way to summarize these perspectives, to add a few more very important thoughts. This comes from my colleagues at MIT, the joint program. I was working with them for many years when I was at MIT. And it's a way to communicate this to the public. Where are we? Well, we are sort of playing a game of roulette because the climate is complicated, even though, as I insist, the consensus is very clear. But the consensus is also that we don't have absolute certainty, but it's no doubt the very serious risk. But the idea is that if we were to continue emitting carbon dioxide, burning fossil fuels without change, as we're doing today, we would be like playing a roulette in the left-hand side. So it's even possible that the temperature could go up, say, more than 4 or 5 degrees. And that's like Russian roulette, okay? That even if it's not the most likely thing, having 20–30% probability of what could be enormous changes in some parts of the planet with enormous consequences for society, okay? Because these are things that have happened only occasionally, even in millions of years of paleoclimate studies. Okay, so that would be very worrisome. The Amazons could disappear. The conveyor belt that brings the temperature that Europe has could change. All sorts of things could change. It's not clear. But it is a very well substantiated risk. It's not negligible. But that can change if we were to reduce emissions, as discussed, as I showed you in previous graphs. And so you will still be gambling, but at least you have a much better probability of not reaching a very high temperature. But most importantly, from an economic perspective, okay, I insist here now, let me put the word economy back in the discussion here. What you eliminate is the red zone here. And economists, sort of Weizmann at Harvard and so on, they explain to us that society should make decisions based on these so-called fat tails, these probabilities that we will have real disasters. Some other economists, like Nick Stern, I know very well, and so on, they calculate what would it cost to change this, what's the most likely cost. And surprisingly, it's not very much. We're talking about around 1 or 2% of global GDP. Okay, so between about -1 and +3, it's quite uncertain. But here is the point: the cost of the damage that we're already seeing from extreme events is clearly larger, and the potential cost from these very high temperature changes is just extremely hard to calculate. But that would be very, very much larger. Okay, so the bottom line here, let me see if I could, I want to go to the last one. If I could click down there, but I don't have a choice. So I'm going to just to move fast. I'm just going to let you know what this was in case you want to discuss it, but we know how to calculate the cost of various energy alternatives. It depends on the interest rate you use. One of the win-win measures is to remove subsidies. Fossil fuels are quite heavily subsidized according to OECD studies. But anyhow, I'm finishing with this. The point being that 1/4 of the human population is the one that has caused these emissions that we have now. But the rest of the population, the planet, of course, has the right to increase their standard of living, to use energy and so on. And for economic reasons, it would be much more advisable to limit emissions, even if you consider just the most likely thing rather than managing this risk of not doing very much. But let me finish with, besides stressing the point that the economy has very clear indications here, there is a very important ethical point here as well, and you cannot, that doesn't come from science. I cannot, as a scientist, tell you what to do. Science can only tell you what happens if you do this or that. But as an individual, we can certainly all can talk about values and responsibilities, and given the well-established magnitude of the risk, it would be, how should I put it, it would not be something responsible to do for future generations. And we're not talking only for the end of the century. We're already talking about our own children, so it's already happening. We'll be irresponsible to gamble and to leave a changing planet where it would be conceivably much more difficult to reach or to maintain the standard of living that we already have. I think I better stop here. Thank you for your attention.
Muchas gracias.
Thank you very much. Thank you, our panel of experts that we have here with us, and we thank them for their presence. I would like to open the table, to open the floor, so that our participants physically in the meeting and those who are on the webinar would have the opportunity to make a comment or ask a question directly to the doctor. I would just like to emphasize 2 or 3 things. The first is that Dr. Molina spoke at the beginning of his presentation about the national strategies in our countries with regards to energy. And one question that we have to ask ourselves is how sustainable are these strategies, and do they go hand in hand with the topics that have to do with the environment and natural resources? Second, we have to ask ourselves if the strategies that we have in our countries go in the same direction, or Canada is going one way, the United States the other, and Mexico the other way. What do we need so that those strategies can be strategies that are compatible at a given moment? The doctor mentioned the relationship between energy and climate change. All this issue of how do we perceive it, the outside population. But there's a consensus in the scientific community talking about the 97% that say that this is happening, and that it's happening due to human activities, and that because of what we're doing outside. All this linked to the increase in temperatures and the implications that they have with regards to national phenomena like hurricanes, fires, floodings that have increased. And the doctor mentioned that we have been seeing with more intensity. What is interesting in all this is that with this reality and with this problem, we have the Copenhagen Agreement to reduce emissions so that the temperature in the planet doesn't increase 2 degrees, and options and possibilities that we have for the future that Dr. Molina mentioned. And one question is, what is happening? Why are we getting ahead of ourselves if we already have the options at the table? This is a cost issue? Is it policy? Is it politics? I wanted to present these ideas so that we can start warming up our guests. This is a synthesis of what you have mentioned, Doctor, and open the floor for you who are here and those who are at the webinar so that we can ask direct questions to Dr. Molina, please.
Somebody might ask, but just to expand on your conclusions, just very briefly, things I should have said I didn't have time. Of course, there are losers and winners. Some of the impacts of climate change could be beneficial. In northern countries, they could have longer growing seasons and so on. But in general, we're worried about changing the stability that has led during the Holocene to the progress of civilization. That's just point one. Just make sure that we recognize, of course, that some will end up winning, but overall it's a worry. But the second point is more a question to you. And it has to do not that much anymore with climate change directly, but with energy and with energy strategy. As you know, the United States, a very big change in recent years is shale gas, of course. The price of energy has really crashed. The United States is in much better shape, so they don't have to import that much. But natural gas is several times cheaper, not just half as much. It's 1/4 as much as in Europe, something like that. So that affects the economy in an enormous way. Fortunately, it turns out that gas, at least as a transition fuel, fossil fuel, is much better than coal, because for the same amount of energy you emit half as much CO2, because of course methane has 4 hydrogen atoms. Okay, so the one worry is not to see gas as something for the rest of the century, but just as a transition fuel. But it's having an enormous economic impact. So one question I have, if we do some North American thinking, what do you do with these sort of non-conventional fossil fuel sources like you have here in Canada and so on? How are the costs of these types of energy? How do they compare with what you can get with shale gas? You know, that's why the United States is getting back some of the factories that they have exported to other countries. It's now cheaper to produce in the U.S. because the price of energy has dropped so much. And in Mexico, we have a potential to develop shale gas also, but we have to build the infrastructure, gas ducts and so on. But you don't have to liquefy it and export it overseas, which is what is very expensive. Anyhow, that's just a question I think that is important for energy strategy, and specifically in connection with Calgary, with where we are. What's the perspective of these new developments?
Sí, posiblemente, y me parece que es muy atinada su comentario.
Your comment is correct, and this is one of the questions that we can ask at the tables in a little while. So I would like to thank you. And if you have any more questions or comments, first here and then the other side.
Thank you very much for your excellent presentation. One of the slides that you had was the one on scientists are 90%, 97% convinced that CO2 and global warming is very much connected, and 3%. I think the question to you would be, governments act when the public are convinced of an issue. And I don't think the public is convinced about this as much as maybe all of us in this room are convinced. And until the public is convinced, it's going to be very difficult, I think, or they probably won't act until that happens. And I think that President Obama has seen this himself within the Congress, but perhaps within the population. Do you have any insights on how, as a public figure of you in the universities and influencing young people, how we can project this in a more meaningful way in order to convince the general public?
Sure, it's a very important question. And first of all, let me repeat sort of the bottom line. We recognize in the scientific community we have done a very poor job in communicating this to the public. Scientists normally communicate in complicated language, and they are so careful. They say, yes, but this and that on the one hand, on the other hand. So it appears that everything is very uncertain. There are, of course, uncertainties, but you have to use the right language. Anyhow, there is an effort now in the scientific community to use professional communicators. And some of us are learning more about communicating precisely to do a better job. Because we have to counteract the job that was done on the other side that was very well done, and by the way, very well documented, that it was based on the same people that were involved with the smoking issue. Okay, they managed to delay government regulation for nothing less than 20 years because they sort of inserted doubt, questions in terms of, is the science clear? Okay, so we have to do a professional job, and fortunately, of course, I have to mention the Republican Party. First of all, I have some very good Republican friends, George Shultz and Bill Riley and so on, who are very much in agreement with us. But it's just that it became a point of the Republicans in Congress at the moment, some years ago, to have this as a party position. But we're talking to some of them, and that's beginning to change. Why do I mention this? Because we have to do both things. It's too slow to just count on educating, say, young children. That would take a long time. So we have to directly communicate with policymakers. And I think that's beginning to change because there are some options that are clearly beneficial for the economy. So there's some hope that things might begin to change in the next few years because of all this change. And that's why Sandy and some of the extreme events have turned out to be very important. However, unfortunate the events were, but people are beginning to see something close to them. It's not just for my great-great-grandchildren next century. Okay. So that's being reflected in the polls nowadays.
Thank you, Doctor. Please.
Thank you. Good morning. My name is Angeles Mendoza. I am from Mexico, but I also live here in Calgary. My question is about national strategies and sustainability. I've been researching extensively, for instance, the national policy of Mexico on developing wind power, especially in the isthmus of Tehuantepec. And there are lots of social and environmental impacts together with violations of human rights and indigenous rights. So I wonder if, through your research, you have come to some sources that analyze these costs, not only, so the cost of national strategies, not only in the economic sense, but also in the social and environmental side.
Making a very important point. We are trying to do that, but we're looking at what experts are doing as well, which is not just the environment, but it has to be environment and economy, and of course the social issues as well. That's extremely important, and you can see that well, the clearest example is if you want to introduce clean stoves in very, very poor families, it has an important climate connection because it turns out that black carbon soot is also a very important climate forcer. And Mexico had a program which they did not take into account the social components, and India as well. And so the government invested a lot in these stoves, and people just didn't use them because they didn't like to cook them. Okay, so that's just one. But with wind, of course, the bottom line, without spending too much time, the bottom line is that you are right. One has to look, let's say, from cradle to grave at all the costs and the social issues. And even winds, of course, they all have impacts. But the same thing with nuclear and so on. If you look at the overall picture, you get a better idea, and that's the only fair way to really compare them. There are other issues. We're talking about Mexico. Mexico has, you know, a new climate change law, commitments to reduce emissions, like I showed, 50% by 2030 or something. But in small lines, of course. However, we can only do that if there's an international agreement. Of course, because you have to worry about the overall economy. Okay, Mexico cannot possibly jump ahead and lose competitiveness. That's why I was talking about shale gas and so on. You have to have your feet very clear on the ground. How much is energy costing? But if the entire planet agrees, or at least the rich countries, the impact on the economy is not very large. That's what is surprising. But yes, social issues are particularly important. I have lots of examples. We're worrying about the construction sector, where we deal, of course, with the environment. You have to build houses that are much more efficient, but also the economy. They have to pay for themselves, and they already happens with the price of energy, as we have to. But you have to build them so that people like them, and they have schools and so on. So yes, those three elements are fundamental for sustainability. So we're talking here about energy, but if you talk about sustainability in general, you have to have this overall perspective very clear.
Yeah, sorry, just to complete. Yeah, and I think I agree with you, and I think that especially the themes of indigenous and human rights are very important to incorporate in national policies. Thank you.
Sure.
Thank you very much, Dr. Molina. That was a terrific talk. I wanted to follow up on something you were getting at earlier and just read this quote I read recently from 1989. So this person said, by degrading the land surfaces, by polluting the waters, and by adding greenhouse gases to the air at an unprecedented rate, all this is new in the experience of the Earth. It is mankind and his activities which are changing the environment of our planet in damaging and dangerous ways. The environmental challenge which confronts the whole world demands an equivalent response from the whole world. Those countries who are industrialized must contribute more to help those who are not. That, believe it or not, was Margaret Thatcher in 1989. And she backed away from that because of the Merchant of Doubt folks, and later said that dealing with climate change looks like a marvelous excuse for worldwide supranational socialism. And this is really the fear behind these doubt merchants. And so, you know, so the fear is that it's going to be a lot more collective government action that's going to be required, and it's going to restrict a certain notion of freedom and liberty, and that has tremendous power in many places, but I think especially in North America. So I think more specifically on that is, you know, how do we address this sort of culturally embedded and very powerful notion of freedom and liberty, which has really held action in this part of the world and elsewhere in check?
That's an important question. And you really put it very clearly, which I didn't have time to spell out. Why is it that the Republican Party in the United States has this position, of course? And yes, if you go to the extreme of the Tea Party, they were extremely worried about just the government interfering with your personal options and so on. But the point is that it's not essential for government intervention to interfere with your private lives. Just take a look at this. One of the conclusions here, put a price on emissions. One way to do it in the United States is, sure, you collect the price, but you give it all back to the people, all back. So the government doesn't keep anything, and it doesn't tell you anything more. Okay, so there are certainly ways to do it with very little government intervention. But you have to recognize that there are limits. And the one I worked before personally in Mexico and in Los Angeles is you have a very polluted city. And you say, wow, people can no longer live here if we continue this way. So the government has to impose regulations, and they have to impose the need for catalytic converters, because people would not do that voluntarily. But if you don't do that, we would be living in Mexico City anymore. Okay, so there are some obvious things that the government can do, and they can do it well, but they can do it very poorly as well. So your point is well taken, but it's not. See, the conclusion is what is wrong. That given the fact that potentially the government can interfere here, that means let's do nothing about it. The hell with future generations. That should be their worry. My own children, well, I won't be alive when they are older, so who cares? No? I mean, it's about that. Going back to Margaret Thatcher, that's very interesting. She was very prominent with the Montreal Protocol. Okay. And in fact, the Montreal Protocol, and with her help, established the multilateral aid. That means the developed countries put resources to help the developing countries, and they all agreed, and the CFCs were completely banned. And it was almost nothing to the global economy, okay? And the problem was solved. So we do have a precedent that it can be done. Of course, the government had to impose something, namely, don't manufacture these things anymore. You cannot go to the extreme that some of the Republicans, I forget, some of the Tea Party. In the U.S., if you remember, they tried to pass a law not that long ago. I, as an American, have the right to use whatever light bulb I like, even if it's extremely wasteful, because that's my right as a person. No, because you're affecting other people. Okay, that's what they don't take into account. You have to take into account the whole progress of civilization. But yes, very important point, I agree.
Muchas gracias. Al doctor Molina, gracias a todos por sus preguntas.
Thank you, Dr. Molina. Thank you, all of you, for your comments. So we will keep on with this session, the agenda. So we will try to meet our times. Fortunately, doctor is going to be with us for the whole day. Any question that might come up, you can come close to him and ask him. So right now we have our roundtable for experts, and we are so fortunate that we have with us Gordon Lambert, Kit Gord, and Ricardo Samaniego for this expert panel discussion on the same topics we have been dealing with. And I would like just to refer to each one of them, and then I will give them the floor. So, Gordon Lambert.